So, what is the slope of the line from x equal to 0 to x equal to 2? Just anybody. What is the slope of the line from x equal to 0 to x equal to 2? What is slope? Do you guys remember that? What is slope from algebra 1? What is slope? Rise over run. Somebody said rise over run. That is correct. Rise over run of any 2 points. Yes. So let's do this rise over run. So let's go ahead and do that. The slope is m. M is slope. Is rise over the run. So if the slope is rise over run, then we can go ahead and do a rise up. I'm going up 2, and then we're running 2. So rise over run, 2 over 2. So it's 1. Okay. So we're rising up 2 over 2. All right. So here's the next question. If I asked you here, if I just pick any other point here on the line, let me pick this point right here. Look at it. I pick this point on the line, and then I pick maybe this other point on the line. Tell me, what is the slope from this point to that point? What is the slope? Huh? What is it? Somebody's already saying, figure it out. Go ahead and do it. Let's figure it out. What would it be? If we're going to go ahead and figure out what it is, it's going to be what? How much am I going to go up? 1, 2, 3, 4, 5, 6. So I am rising up 6. And then how much am I going across? 1, 2, 3, 4, 5, 6. So what is 6 over 6? It's 1. Look. You really need to understand what a slope is. Slope of a line means that no matter where and what I choose, the slope is constant. The slope of a line is constant. It's the same. And I don't even need 2 points. If it is on the line and it is a line, the slope here all by itself is changing at a rate of 1. At a rate of 1 over 1. So the slope of a line is constant. And you really got to understand that for what calculus is. So here, say you got 2 points, no? You got these 2 points. But what's happening in between those 2 points? You got these 2 points. This could be a curve going like this maybe. I don't know. It could be like this. It could be something going like this. But then they wouldn't be constant. See, we don't know what's happening between. The only way that it will have a constant same slope if it was a straight line. Other than that, it is not constant rate of change. Okay, so we got this. Go ahead and copy this down. So I hope you notice and you know that this right here is not a line. So this is a quadratic equation. So now, this is not, when I say what is the rate of change or what is the slope or the function of this, I cannot call it a slope. It's an average rate of change. Because the rate of change keeps changing. If you understood what I just said, the rate of change is changing. Now, so you guys are copying this down. say for example, I'm going to get off from what is exactly, this is asking what is the rate of change, what is the average rate of change from x equal to 0 to x equal to 2. But if I was just to ask you for this particular function, which is a quadratic, and I asked you this, what is the rate of change at x equal to negative 2? If I was, it's just a thought. What is the rate of change? Just to think about. Of the function, what is the rate of change of the function at x equal to negative 2? What is the rate of change of the function at x equal negative 2? If you know what is the rate of change of the function at x equal negative 2, you should already go to college. You should already go to, I'm going to write to Princeton or somebody. I'll be like, hey, you know what? This person needs to be right there right now. What is the rate of change of the function at x equal negative 2? See, all I know, is that it's going to be negative. It's going to be a negative slope, because this is what's happening here is that it's going down. It's a negative slope, but I don't know exactly what it's doing. It's not a line. It keeps changing. Whereas if I ask you like something like, what is the rate of change here? Well, what is the rate of change here then? Anybody at x equal to 2? Say at x equal to 0. Rotoid. Yes. When we're done? Okay. What is the rate of change at x equal to 0 of this function? Anybody? What is the rate of change at x equal to 0? What's the rate of change here for the function? Nobody? Well, a horizontal line, are we rising up for any horizontal line? Do you know what slope is? We already said. What is slope? And you already told me. What's slope? Slope is rise over run. And I'm telling this is the line. So how much am I rising up? Huh? No, I'm not even rising up. It's what? 0. And how much am I running? Well, it could be any number, whatever. You could just put it 0 over 5. What's 0 divided by 5? 0. Okay, here, put it somewhere and remember this. A horizontal line has a slope of 0. A horizontal has a slope of 0. Anything on the left side is negative slope. That's for sure. I don't know exactly what it is, what number, how much is it going down and then across, but that's definitely a negative slope. Here on this side, this is definitely a positive slope. So anything on the left is negative slope, anything on the right is positive slope, and directly here the slope is 0. That's all we know. Okay, now what we are going to get is a secant line. And then we're just going to say that the slope, the average of all the slopes in between x equal to 0 and x equal to 2, the average rate of change between 0 and 2 of the curve is going to be whatever we're going to get right now, which is going to be rise over run, which we're going to do the average rate of change. Actually, let me write it down the way they do it in the AP people. AROC. We're going to call it AROC. Average rate of change. It is just the rise over run, but it's the average rate of change of the curve. Okay? And that's going to be rise over run. But the meaning is different because it's just the average rate of change of the curve. We're saying that the curve averages out to this. Oh, at every point. See, every single rate of change here, at the end of the day, averages out to that. Which is just going to be rise over run. So what is the rise? How much am I rising up between the 2 points? And 4. So we're rising up 4, and then we're going over what? 2. So the average rate of change is 2. Now, we already know that's the average rate of change. I'm going to give you this formula that is going to be the foundation of what calculus is going to be. Let's call this point A, and let's call this point B. The x value, let's call it A. The x value is A. The B value, the other x is B. Let's go like that. So if I'm going to go like this, and I'm going to call this A, no, the first one is going to be, the second one is B. So B minus A, then I'm going to go F of B minus F of A, which is rise over run, F of A. This is going to be the foundation of it. The x value of this point is 0. The x value of this second point is 2. So let's go ahead and find the average. We already did, but we just want to do it a different way. We already know what the answer is. It's the same, but the answer is 2. Let's verify it doing it this way. So B is the x value of the second point, is 2, minus the x value of the first point, 0. And this is, we should be familiar with this, no? Function notation. What is the function of 2? Okay, we do function of 2 here, minus the function of 0. When we say what is the function of 2 is what is the y value of 2? What's the y value of 2, everybody? What is the y value of 2? 4. Hey, look up here. This is important, everybody. What is the y value of the second point? Well, the y value of the second point is going to be 4. So you put it here. The y value of f of 2, or the y value of 2, the y value is going to be 4. Minus f of 0. What's the y value of 0? 0. So now at the bottom, we already got 2 minus 0. Let's go 2 minus 0. So on top, what's 4 minus 0? What's 4 minus 0? 4. And what is 2 minus 0? And what's 4 divided by 2? 2. This is the average rate of change. This is called a secant line. This is a secant line. So the average rate of change of the curve is this 2. But it's not the exact rate of change at any one of them points. Maybe it will be at one of them points, but we'll talk about that when we get to calculus. At least one. That's what we need you to understand for today. This average rate of change is this formula right here. All right, so use the formula right now. Go ahead and use the formula to find the average rate of change of this curve from x equal -1 to x equal to 2. We're not doing rise over run, which for the line, it would be the rise over the run. But for the curve, we want to use the formula, no? Oh, not M. We're doing average rate of change. Yeah, I'm not gonna just ask the class because nobody wants to come up. I'll be the one that always does. You want to do this, Brian? Is okay? You want to do this? Come up and do this? Yeah, I'll show you. Yeah, come up. Yeah. Okay, everybody, this is what you need to know and be very proficient with it, all right? So, Brian, let's focus like this. What's the B value? Okay.
That one, right?
Oh, it's the second one. Okay, better go like this. Go in the first point on the left, and go down the first point, go down to the -1 and circle the -1. And draw kind of dash line from the point to that thing. And maybe use red because you can barely see that number. Yes. Dash it and circle that number. And circle that -1. That is going to be A. Go ahead and put A there. A. Right next to it somewhere, like it's A. We know that's A. And you like capital letter, that's fine. Go to the second one and go dash it down to 2. Circle it. That is B. Okay? Yes. Go back to over here to A rock and replace the B with what?
With -1. Oh wait.
B is 2. B is 2, no?
Oh no. Yeah. I was thinking of this one.
B is 2. Put 2.
Yeah.
No, why are you putting it up at the top? No, we're doing it at the bottom. The bottom. We're not even focused on the top. We want to go B. That B is 2. No, why are you putting it there?
Wait. So you don't want me to like put it right here?
B. The B is the bottom.
Yeah, I know
what I'm talking about. B.
Oh, you want to?
No. In the equation. But step with that. In this era.
Right
B.
here.
B. The letter B.
Right here?
No, not well. That's a letter, but just the B. The X value is B.
I know, but
So put it there, but why are you putting it on top? It's
you
at the
want to
bottom.
put it right here.
Yes.
You just said that.
Minus A. What is A?
-1.
Yes. Now, go ahead and do F of B. F. Put F of. Yes. Yes. Okay, A rock. Go ahead and put your A rock. Continue. Next step. A rock. Equals. Yes. Draw your line. Okay. So hopefully you got no problems with these with this arithmetic. What's the answer to the bottom? Just write down the answer. What's 2 minus negative 1? Okay, you're good. You're good. Yes, yes, yes. Okay. What is f of 2? What is f of 2? Look at the graph. What's f of 2?
Two.
Okay.
Wait.
Let me help you. Let me help you. F of 2 is the y value of the x that corresponds to the x on the function. Okay, let me show you. Go point to the b, the b. Go point to the b x value there. Now go up. Go up.
5, right?
Huh?
5?
Yes, that would have been the answer, but you will go. You do this. No. Go back. Do it. That's for everybody. I'm doing this whole. Look, Brian, look at me. You're gonna go like this and then go across to the.
Oh,
Go. Do it. Just do it. Yes, and then circle 5. Get rid of those lines. I don't like seeing those lines. You would have done dash line to it better than that. I don't like doing that.
wait.
No, erase it. And I didn't want you to touch it. I want you to just kind of show me that you know what the y value of 2 is. The y value of 2 is 5, Brian.
Yeah, I told you that, but like you're confusing me.
Yes, and circle 5. What? Okay, step back. F of 2 is 5. So 5, put there 5. Minus f of negative 1. What's f of negative 1?
2.
Yes. Finish it. What's 5 minus 2?
It's 3.
And what's 3 divided by 3? Okay. Yes. Yes. Yeah, go ahead and sit down. Don't do it. Don't. You're good. Go ahead and sit down. You got it. All right. So, we should know already what the answer is, and the answer is rise over run. The answer is 1, 2, 3, and it's 3 over 1, 2, 3. The answer is 3 over 3 is 1. But the problem is that you guys don't even know what is this, and how to find outputs for inputs. You know what? I don't even want to do this. Don't copy this down. Let me just talk about this real quick. Which of the following functions has the greatest average rate of change over the interval from 0 to 6? So this is not an average rate of change. This is it's a line. So the slope is whatever the rate of change is between any 2 points. It's going from 0 to 6. 0 to 6. So whatever this rate of change is, which is rise up what? 1, 2, 3, rise up 3 over 1, 2, 3, 4, 5, 6, 3 over 6. This is slope of the line, which is 1/2. So the slope is 1/2. And it's not an average. It's an exact rate of change because it's a line. At every single point, the rate of change is 1/2. Okay, so now here, this one is an average rate of change. Why? Because it's a curve. So for this curve, whatever I get is going to be an average. So this is going to be what? 1, 2, 3, 4. Is it? 1, 2, 3, 4, 5. Over 1, 2, 3, 4, 5, 6. 5 over 6. So now tell me, which one is bigger? Is 1/2 bigger or 5 over 6 bigger? I think 5 over 6 is bigger than 1/2. So that one has a greater rate of change than this one. The steeper it is, the greater it is. So if this one is like this and this one is a little less, then that one has a greater rate of change. Okay, so I wasn't gonna do this,